hello, good morning, good afternoon, good evening. Thank you all for joining me today for our webinar. So this is Terrestrial LiDAR for Surveying. For any of you guys who don't know me, my name is Jillian Kreider and I'm the TLS Sales Specialist here at RIEGL USA. So if you guys don't mind, I am going to start today's webinar by asking you a poll question. So let me pull that up really quickly, and then that way I can hide this little bad boy and get this out of our way. So are you guys currently using RIEGL LiDAR for surveying? So our answer choices are yes, no, or I would like to. So we'll give you guys a few seconds to keep answering. Seeing a very interesting split. We've got a good number between yes and no, and we've got some guys that would like to, so I always like hearing that. Obviously, I'm always around if you guys have questions, and so is Tan. So I'll wait about another 5 seconds or so, and then we'll close the poll and we will get started with the day. All right, perfect. So just so you guys can see where we were at with everything. So we had a pretty good number of you guys are already using RIEGL LiDAR. We've got some of you guys who are not and some of you guys who would like to, which is always fantastic to see. So what we're actually going to go ahead and do now is we'll just go ahead and get started once I can get my screen back up. Bear with me. All right, let me hide that, and then we should be good to go. Fantastic. Let me hide my control panel. Awesome. Okay, so let's go ahead and get started. So just really quick, I'm going to go over the agenda for today's webinar. We are going to discuss why we use LiDAR for surveying, or why you should use LiDAR for surveying, some terrestrial hardware and software developments from RIEGL, and we're also going to show a real-world example. So during the webinar today, if you guys have any questions, please feel free to drop them into the question box. We are going to be a little bit pressed for time just because of the amount of content we've got to go through. And I'm going to try my best to get to the questions. If for some reason I can't get to the questions, just leave them in that question box and I will answer you guys via email or phone call if you would prefer after we're done today. So before we hop into it, I'd like to thank Laura over at Olson. She sent in some really great pictures of some surveying projects that they're working on. So as you guys can see here, it's a real world example of a roadway, some building structure. So we're in an urban environment. So that's the screenshot, or the image shot that's over on the right. So what are some of the major benefits of using terrestrial LiDAR technology for surveying? So obviously the first one is that it can help you increase your data collection productivity. So by utilizing RIEGL LiDAR or other LiDAR for your surveys, you're actually going to see an increase in efficiency both in the field and in the office. Essentially, this is fast scanning for surveying professionals. So you can also reduce your field time. So with that increased speed of data collection, the time you spend out on a job site is going to reduce significantly. You can also reduce revisits. So with the amount of data collected in one trip, hopefully your first and only trip out to your job site, you're going to capture things you may not have thought you needed for that first trip out. And you're going to be able to find that later on in your data back in the office, which keeps you from having to deploy yourself or any of your teammates back out into the field, which at that point increase your project costs overall. So this helps reduce that for you. And of course, we have the increased safety factor. So by using LiDAR to scan a hazardous or a hard to access area, you can actually keep both yourself and your crew safer in the field. So in general, to understand why we would want to use LiDAR for surveying, it helps us to understand how LiDAR surveying itself works on a technical level. So LiDAR works by pointing a laser at a target surface on the ground. The surface then reflects the light back to the LiDAR equipment, and the sensor then records the reflected light to measure the distance traveled. This collected information is then combined with the position and orientation of the LiDAR equipment, which is measured using a GPS receiver and internal measurement systems. This creates 3D spatial coordinates that include latitude, longitude, and altitude, creating a combination of data that's known as a point. So when land surveying with LiDAR, this LiDAR equipment collects millions of these points using those measurement methods described previously. This collection of points, as you guys know, is known as a point cloud. So the point cloud is what a survey is conducted for, and it's that crucial data that companies then use to be able to create the 3D models of the terrain that they are working with. So using RIEGL's ultimate LiDAR waveform technology, high precision 3D data of terrain, structures, roads, highways, railroads, bridges, and other surveying and mapping needs can be acquired with increased accuracy, detail, and fidelity. So benefits that can be seen with using LiDAR for surveying include acquiring highly precise data from a wide area in a short span of time, the ease of use in both the field and office, and the quick processing of your data acquired, which at the end of the day means a faster turnaround time to get a high quality end deliverable to your client, which is critically important to you and your business. So there are some other major benefits of using LiDAR for survey I'd like to highlight now on the next slide. So the three that we're going to go into in a little bit more detail today are going to be speed, accuracy, and safety. So before we hop into that, again, Laura provided us with this amazing screenshot of a drop structure and bridge that they did from a storm survey that I've got up on the screen. Fantastic data, got what they needed to do, really wonderful. So now let's hop into these benefits. So speed. You guys have a limited amount of time to get your measurements, and you guys are often working on a tight schedule due to budgetary restrictions, client needs, project needs, whatever. So using LiDAR actually allows for you to complete your surveys within a short amount of time, and you can work throughout the day and night, delivering results as quickly as possible. Time is money in the field. You guys know this. You've dealt with this. You know that if you can get in and get out and get what you need, it's going to result in a better bottom line for you. By using RIEGL LiDAR, you're actually going to see savings both in the field and in the back office thanks to the speed of the scans themselves. So a normal scan position in our Panorama 40 setting, we can collect scan data and imagery within 45 seconds. And then also with our automatic onboard registration for this for any project. And we will get into automatic registration in a little bit later. So accuracy. You guys need detailed topographic layouts to plan your projects effectively for your client needs. By using LiDAR, you can collect that precise data that you need to get the job done. The accuracy of LiDAR means that it's less prone to human error. With traditional surveying methods, there is a lot of human input from measuring up the total station to adjusting the rod height measurement and prism offset to measuring tree diameters and correctly orienting instruments. All of these measurements are read from a tape and then into a field computer. Now, of course, a good surveyor is going to build in checks to prevent errors, but mistakes are inevitable. Not to mention that if you guys are out there, in the woods, in the swamp, it's hard to keep up with which trees have just been measured, and that can prove to be a challenge. It's really easy to lose track of what's been counted and what hasn't when you're standing in the middle of a forest. So LiDAR helps to remove that human element out of the process, which makes your data more accurate. And then, of course, safety, always safety. So surveys obviously take place in a variety of terrains, some of which can be hazardous or difficult to access. Besides having to traverse through woods and swamps to cut lines, find survey markers, actually conduct your survey, a lot of you guys are working on roadways and highways where there are cars just whizzing by constantly at highway speeds. Now, these are obviously just a few examples of what you guys have to deal with on a daily basis, but overall, these are some of the working conditions that you guys are finding yourselves having to work in with less than ideal safety conditions for you and your crew. So with LiDAR, you can actually collect the data that you need from a safe distance, check it out while you're still in the field to verify that you've got what you needed, and get back to the office, which helps you increase employee safety by keeping both yourself and them out of harm's way. So what are some other reasons why you would want to use LiDAR for surveying? It's a value-added service. So LiDAR is capable of capturing more information more rapidly, and it even often captures information that's not necessarily needed for your project. This helps prevent needing to send a surveyor back out onto the site to capture any additional measurements because all the information is already stored and on site with your crew. So what does RIEGL bring to the table for you in regards to hardware and software that will help you push your boundaries for your survey work? So this is the Vzi 400i. Now, some of you guys, I'm sure, already have one. Some of you guys have the older iteration, which is the 400, possibly one of the 2000i's. But this is the RIEGL LiDAR surveying scanning system that we are going to be discussing today. So this laser scanner itself is an excellent addition to the surveyor's toolbox. This really is a workhorse that's easy to use, easy to learn, and easy to work with. So this is one of the most productive terrestrial laser scanners out on the market that helps to deliver survey grade accuracy and precision for your end use. So the scanner acquires up to 500,000 measurements per second effectively, and it can complete a single scan position in 45 seconds with simultaneous image and data acquisition at our Panorama 40 setting. The scanner's range is from about a half of meter up to about 800 meters, and it's a class 1 laser, which renders it eye safe. The field of view on this is about 100 degrees vertical and about 360 degrees horizontal. So what does this all really mean? This means that you are actually able to capture much larger amounts of data extremely quickly and extremely accurately, so your time in the field is reduced. There are 2 processors on board the system that allow for the VZ400i to perform different processes in real time, such as automatic onboard registration in parallel to the scan data acquisition, which we'll get into a little more detail further down the line. So processor 1 onboard the scanner does the scan data acquisition, simultaneous acquisition of the photographs while you're scanning, and pause estimation using GNSS, IMU, and environment sensors, while processor 2 converts the scan data into the RIEGL database, does onboard multiple time around resolution, and registers the scan data as a background process while you're continuing with your scan project. So essentially, while you're out scanning, it's already working in the background to register your point cloud together. Some other cool features of the 400i include an orientation sensor for pause estimation, an integrated GNSS receiver, an external Nikon camera that helps take imagery to colorize your point cloud, and external RTK GNSS to help you tie your point cloud down more accurately. So now let's jump into the software developments that help aid in surveying. This is really going to just complete the package, so to speak. So the first that we're going to touch on is, of course, Ryscan Pro. Ryscan Pro is the companion software for all of the RIEGL terrestrial 3D laser scanning systems, and it's a fully integrated solution for producing accurate and refined TLS point cloud data. So this is actually designed to help optimize your acquisition workload in the field while providing tools for visual inspection of overall completeness of data coverage in 3D right after acquisition. This is process orientated, which means that all data that's acquired during a scan project is actually organized and stored in the Ryscan Pro project structure. So again, it just makes things easier for you. Some of the advanced features that we have available in the software for point cloud optimization include automatic registration, the multi-station adjustment, flexible filtering tools, data merging, and high-performance 3D visualization capabilities. These tools in the software are designed to actually help optimize the acquisition workflow for you in the field, which makes the partnership between hardware and software complete. Additionally, the data can be streamed in real time from the scanner to the software, where all of the processing features required to produce a perfect point cloud are provided. It's a lot of alliteration. Giving you the ability to perform real-time QA/QC of data coverage and scan registration in the field. This allows you to be able to check your work before you go back to the office, which is important. It helps prevent from secondary trips to fill in those data gaps, and it'll save you time and money in the long run. So the data, once processed through the software, can also be exported to a variety of third-party softwares in a variety of formats, making it extremely flexible to use. I know a lot of you guys will export this to different CAD softwares, and we have absolutely no problem having a file format that's compatible with those systems. So we've also built into the software a tool that we call GSS Manager. So this manages a database that contains a set of coordinate reference systems, their underlying geodetic datums, ellipsoid models, datum transformation parameters between those geodetic datums, map project parameters, and geoid models. So in layman's terms, this really just means that it helps to enable your data to be tied down to your coordinate system that you choose to work with, and it helps lock you into your position in the world for further accuracy. Survey control can only be applied here in GSS Manager, and this applies the coordinate system, which we will actually then tackle in the next few slides with MSA2. So that being said, here is MSA2. So MSA stands for multi-station adjustment. It's extremely fast, and it allows your control to be added and to be reported on. So this is used for additional project alignment after the automatic registration on the scanner by taking all of those available measurements into account. So these additional measurements include pause estimations derived from GNSS data and/or IMU data if you're using a Vzi I-series scanner, or the header information of RXP files if you're using a Vzi series scanner. So additionally, the available measurements elements that can be used for this project alignment are the tie points, which are fine scan targets that are linked between the different scan position, observation points, which are fine scan targets without links between the different scan positions, and then control points, which are the external measured points. So after all of this, MSA2 takes the scan data into account by extracting, merging, and matching the plane patches for each scan position. So the MSA2 alignment process does not use voxels, but you can actually create them if you want to do visual quality inspection. So the results of the MSA2 is that you get an optimized registration and georeferencing of all of your scan position in a project by adjusting your SOP matrices. So all registered scan positions will be adjusted by updating their matrices. The frozen scan positions will be taken into account for MSA2, but they stay fixed. So on that one, the SOP matrices of the frozen scan positions are not modified. Registered scan positions that are not taken into account for MSA2 lose their registered state, and then not registered scan positions are just ignored for that. So again, this just helps to optimize your processing workflow and your end data. So now let's talk about automatic registration. This is one of my favorites. So this is a software feature that we've actually built directly into the hardware for the Vzi series that does fast and highly accurate merging of the point clouds from different scan positions. So if you select this option in your workflow prior to starting your scanning task, so for any of you Vzi users, you know that you can create your workflow prior to even going out into the field. You can do this while you're in the office. You can do this while you're on site. But one of the selections is that you can actually choose to add automatic registration, which I do recommend. So if you select this option in your workflow prior to starting your scanning task, your data will actually begin the registration process while you're still out in the field scanning. So with the scan positions, basically once you hit 1, 2, and 3, once you start scan position 3, 1 and 2 will start to register together. So this actually helps to reduce your processing time in the office, because by the time you guys are done scanning for the day, your point cloud is already stitched together and registered. From there, when you get back to the office, it just becomes colorization of your data, tying it down to control, and verifying everything for accuracy. This reduction in time actually really does help to increase your time and your financial savings, because everything's done on board the scanner while you're still out in the field. It just optimizes your workflow and your time. This is such a fantastic addition to the RIEGL workflow, and it's really proving to be highly beneficial, not only to our clients, but to their end users too. So everybody's just really enjoying this for the most part, which is great. So this screenshot here shows the Vzi Project Map. So this is an app that can actually be used to show you the automatic onboard registration for field work. So being able to use this while you're out in the field helps to actually show you the coverage that you've already achieved from your scan positions, because you've seen where you have scanned and what other areas you still need to go and scan. So this way you know where you have been, where you need to go, what you need to do to finish up your loop. So this helps to really ensure that your project is truly and fully completed. So utilizing this app and the automatic onboard registration helps to reduce your processing time, and again, helps to increase your overall time and financial savings. At the end of the day, that's really what you're seeing out of this workflow: reduce processing time in the office, overall time and financial savings. So one of our latest developments is actually a newer software that we have called Rypano. I'm sure a few of you have seen it, heard about it, have it, which is fantastic if you do, but this is a great software. So this is an add-on to Ryscan Pro that really just allows for the fast and easy visualization of terrestrial laser scanning projects. It is required to have a Ryscan Pro license to get Rypano, but the Rypano license is a one-time permanent purchase, in the sense that there's no renewal fee for Rypano when you have to renew your Ryscan Pro license. So the software runs plug-in free in a browser or as a standalone on a Windows or a Mac OS system, and it allows for the quick extraction of plans and views where you can explore your project and extract your plots in the browser. One of the cool things I think about Rypano is that you can actually have many users using it at the same time. So you could send somebody the same data set, and you could send that link out to 10 people. All 10 people could be using it, and everybody would still be able to use it. So no additional software is needed to be installed for your end user. It's free of charge for your end user, and it's easy to use. So with Rypano, once you export the project, you actually can send a web link directly to your end user for their use, so they can review the project, do simple measurements, do marker definition and path definition in the panorama view in the software. So with the Rypano workflow, to create a Rypano project, if you're acquiring a new project, you're starting from the hardware and moving into the software. So you would start a new project with your Vzi 400i. You can include the imagery if you want it, use the automatic onboard registration. Once you're done scanning, you would import this into Ryscan Pro. If you didn't do automatic onboard registration, you would then need to register your project, then you colorize, and then you can create your Rypano project straight out of the software. And you can actually use, there's a built-in exporter, and that will help create your panoramas, the HTML page, and an out-of-the-box server. So exporting existing projects for Rypano is also feasible with a Vzi line scanner. So for any scan project that's been acquired with a Vzi line scanner, a Rypano project can be created directly in Ryscan Pro. But again, you do need to have that separate license either way. So you just, if you have Ryscan Pro and you're interested in Rypano, just give us a call. We can talk through this. And Rypano is just becoming a very interesting and unique addition. It's a great value added software for your end user. So there are different view types available. There's side view, section, and plan view or plain view. With the results as well, you get a PDF document that can be read with Acrobat Reader where 2D measurements are possible, or you get a DXF file with ortho images that can be read and edited with CAD software. So it really just depends on what you and your end user are comfortable with. But yeah, you can do all sorts of inspections in Rypano as well, where you can keep oversight, navigate through, read out the coordinates in either your own user-defined coordinate system or latitude, longitude, altitude, place your markers, and then keep your distances and paths. So for CAD users in particular, you can easily extract ortho views and plots for further use in CAD software. So again, it's just a fantastic value-added software that we now have that really just you can use to drive home the point to your end user and show them exactly what you've been working on. So now we're hopping into our real world example. So this is one that some of you may be familiar with if you joined us at the RIEGL Training Symposium in 2019. So this is the Reunion Resort. This was the location of our training symposium, and this served as a fantastic testing ground for the capabilities of the RIEGL terrestrial hardware and software for surveying purposes. So here are some of the project parameters of the scan project. This was done by one operator with one RIEGL Vzi 2000i, which is the longer range of the Vzi series. Could have been done with a 400i as well. Again, just really depends on the day what you want to use. So it took 8 hours to do 400 scan positions at our Panorama 40 setting. Images were taken while scanning and with automatic onboard registration activated. After the scans, it took about an hour to download and convert the project into Ryscan Pro. There was some error propagation that was evident on some of the closed loops that was up to about 10 millimeters. So from there, MSA2 was actually applied to correct and tie the project down to the Florida state plane, which took only about 2 hours. And another note on the project parameters is that the project was surveyed in GNSS denied areas in and out without any problems, which is great. So this slide showcases the scan positions that were done around the resort with the project app on the left and inside of Ryscan Pro on the right. And that clearly just shows the overlap that was done to survey the entirety of the resort itself. Lot of movement that day, definitely a lot of movement that day. So here we see the results of the automatic onboard registration in our reflectance view in Ryscan Pro. When the data was downloaded from the scanner, it was a fully registered point cloud thanks to automatic registration. So we already had all 400 scan positions in as a registered point cloud, which is phenomenal. So I'm going to go through the next couple of slides pretty quickly because I know we're getting tight on time. So this was with MSA2 applied, that same data set, and we've got another shot of the resort as such. So then this is the chart of the results from the Reunion Resort Surveying Project. Again, you can see the 8 hours to scan, the hour to copy the data over to the laptop, the creation of the Ryscan Pro project, the filters being applied, MSA2 running, the Xray view, which is a newer view type that we have available in Ryscan Pro for you Ryscan Pro users. If you aren't using Xray view, I highly suggest it. Besides it looking just really cool, it's very interesting to actually be able to see the different views that you get from that, the colorization from the image, and then the Octree filter. So again, this is just a really cool shot of the hotel in the Xray data view that we have, like I mentioned, now available in Ryscan Pro that shows the data highlighted. So this is, again, it's another new view type that you can use to actually showcase the collected data to your end clients, just depending on what they're really looking for. So before we wrap up for the day, I do want to touch base on some project setup recommendations that RIEGL has for when you're taking the RIEGL hardware out into the field for surveying work. So the first is to use RTK GNSS if available. So this obviously is going to help you with your accuracy and your precision. It's going to help tie you down to position, ensuring that you're at survey grade accuracy with your deliverables, which at the end of the day, that's really what we want, is we want that survey grade. So if survey controls are being used, always start your first scan position with survey controls and end your last scan position with survey controls. So if any of you guys are users of ours, you know about closing the loop with your project. So you want to start and end pretty much in the same position. So that way you know that you have a complete point cloud. So always begin and always end your last scan position with those survey controls to close your loop. Use at least one survey control for every 10 scan positions. Just again, that known survey control, use that to lock yourself in. Use that to keep your accuracies tight. Fine scan the survey control from 2 scan positions at whichever position you choose, and then that next position to help create control tie points. Again, to drive it home, it just really helps tighten down your accuracy. And then use at least one survey control when turning a corner. Now, I'm really sorry because we are tight for time. I do want to thank you guys all so much for joining me today. If I'm not going to have a lot of time to answer questions on the air today, but if you guys have submitted them during the webinar, I will respond to them today or tomorrow via email or phone call, depending on whichever one you would prefer. Additionally, my email address is up on the screen right now, as you guys can see, which is jkreider@RIEGLUSA.com, or you guys can even give me a call here at the office. The number here is 407-248-9927. Thank you guys all so much for joining me today. I hope you guys learned something new, and I hope you guys all have a really great day. Thank you.